Hello students, welcome to video session. In the previous class, as you know that we have started the problems on stress strain, and also we have solved some basic problems and two little bit complicated problems. In this session, let us continue the same problems, but in today's class, I'll be solving problems on elastic constants or engineering constants. So this is what problems on elastic constants or engineering constants E, K, and G. First, let us see the question. Students, these questions are very important. Especially, you'll get one question from this concept. That is problems on elastic constant. At least one question. 100% you'll get one question from these problems, and also you'll get one more question from the basic questions. So just you do a bifurcation, basic questions and problems on elastic constant, so that you'll get two questions of 10 marks each. Okay, let's read the question. A metal bar 50 into 50 mm is subjected to an axial compression of 500 kilonewton. The reduction in length is 0.5 mm over a gauge length of 200 mm, and increase in thickness is 0.04 mm. Find a value of elastic constant. Students, this is a question. Now let's take the given values. Let's write down the given values. The B is equals to B into T, whereas he has given, students, in the given question, he has given a metal bar of 50 into 50 mm. That is nothing but breadth and thickness. B into T is nothing but breadth into thickness. So that's why I have written B into T is equals to 50 into 50 in terms of mm. As we all know that he has given in mm, so it is 50 into 50. And later, axial compression of 500 kilonewton, that is nothing but load P equals to 500 kilonewton. Next, the reduction in length is 0.5 mm. Reduction, any change in length is taken as delta L as 0.5 mm. Or a gauge length of 200 mm. Gauge length is nothing but L equals to 200 mm. And increase in thickness. So anything increase in thickness or decrease, it is taken as delta T. Delta T is equals to 0.04 mm. He has asked us to find value of elastic constants. Elastic constants is nothing but E equals to question mark, K is equals to question mark, and G equals to question mark. It's one of the very important questions, students, on problems on elastic constants. Okay, before going to the solution, let us check whether the unit conversion is required or not. In case of B into T, it's not required. In case of PS, we require the unit conversion. So unit conversion becomes P equals to 500 into 10 power 3 Newton. In place of kilo, I'll write 10 power 3. What about other parameters, other given values? No, it's not required because all units are in mm. So this is an mm. So no need of a unit conversion. Okay, as usual, first I'll start with the area. Area is equals to B into T. Students, in the previous questions, I have taken a formula like area equals to pi by 4 into D square, because in that problem, we have a diameter. It was a problem on circular rod. Now it is a problem on metal bar. So for every bar, we'll be having breadth into thickness. So instead of taking area equals to pi by 4 into D square, we are supposed to take A equals to B into T. It's very simple. So just substitute the values. Before substituting the values, just check how many unknowns are there. So area, A is unknown. We don't know the value of A. Yes. What about B? Yes, we know. What about T? Yes, we know. So we have only one unknown. So we can solve. So A is equals to 50 into 50. That becomes A equals to 250, 2500 mm square. Next is stress. The formula is F equals to P by A. Just cross check whether can we solve for this formula or not. F, is F given? No, it's unknown. What about P? P is given. What about area? Just now we have calculated. Right now we have only one unknown, so we can solve this formula. Just substitute the values. F as it is, and in place of P, I'll put 500 into 10 power 3 Newton divided by area is nothing but 2500. On calculation, so I'll get the value of F as 200 Newton per mm square. This is the value of stress. So now it's time to find the strain. The strain, the formula is E equals to delta L by L. Students, I am finding out, right now I am finding only the strain. It's very important to note there are two types of strain. One is the longitudinal strain, one is the lateral strain. Right now I am finding only the strain or longitudinal strain, both are same. So I'll call the same. So E equals to delta L by L. So just cross check. Can we solve for this formula? E is unknown, delta L is known, yes. What about L? L is known. We have only one unknown. So we can solve for that formula. E is equals to delta L is nothing but 0.5 divided by L is nothing but 200. On substitution, I'll get this equation. Once it is done, then I can go for the calculation. So I'll get the value E equals to 2.5 into 10 power minus 3, and it has no units. Well, after strain, I'll go for Young's modulus. Young's modulus formula is E equals to F by E. Just cross check. Can we solve for this formula? Young's modulus is unknown. F, we know the value. Just now we have found out. What about E strain? Yes, we know the value. Just substitute the values. E is equals to 200 divided by 2 into 2.5 into 10 power minus 3. Just a substitute. I am substituted the values of F and E. Okay. Just on calculation, I'll get the value of E is equals to 80,000 Newton per mm square. This is the value of Young's modulus. Students, now I am done with Young's modulus. Next step is to find lateral strain. Since these problems are on elastic constant. Students, how do you identify that this question is on elastic constant? Means if you have a Poisson's ratio in the question, if they have given a Poisson's ratio in the question, then it indicates that it's a problem on elastic constant. Okay, and if he has given that change in dimension other than length means it may be a breadth, thickness, or diameter. If he has given change in breadth, change in thickness, change in diameter, then such kind of problems are problems on elastic constants. It's very simple. First you need to understand on whether this kind of problem is on elastic constant or not. Okay, one is first you check for the Poisson's ratio. If it is Poisson's ratio, then it's a problem on elastic constant. If he has given change in length, change in thickness, change in breadth, change in diameter, then such questions are on elastic constants. Okay. Right now he has given change in thickness delta T. So definitely it will be a problem on elastic constant. Okay. Once I'll get Young's modulus, then I'll go for lateral strain. So this is the lateral strain. What's the formula for lateral strain? EL is equals to delta B by B or delta T by T. So this is very important, students. So in case of lateral strain, you are supposed to take other than length as a reference. While explaining you about different types of strains, I have clearly given a shortcut, I clearly given you a hint how to write a formula for linear strain and lateral strain. In case of lateral strain, always remember you are supposed to take other than length as a reference. In this case, what are the dimensions that are other than length? It is simple, breadth and thickness. So that is why I need to take both, not only one. I am supposed to take both. Okay, other than length is B and T. So I should take EL equals to delta B by B or delta T by T. Students, you make a habit of writing both, or delta B by B or delta T by T. Okay, done. So just now you just analyze whether should I use delta B by B or delta T by T. So from the given question, from the given data, delta B is unknown. So we know the value of delta T. So we can take EL equals to delta T by T. Okay. Even if we know the value of delta B, then I would have taken delta B by B. Okay. You can take both. So that is why I need to write the formula as delta B by B or delta T by T while selecting. So just cross check with the given values. Since I know the value of delta T, so I am taking EL equals to delta T by T. So just to substitute the values, EL equals to delta T is nothing but 0.04, T is nothing but 50. See, this is the T, T is equals to 50. Students, and once again, you make a habit like you are supposed to write B into T. Just below that B into T, you are supposed to write the 50 into 50. By chance, if you don't write B into T, now you'll get a confusion. What might be the value of T? Because nowhere you have written T. If you skip this, If you skip writing b into t, you'll go through the given values and you'll not find the value of t itself. So if you make a habit of writing b into t, then definitely your eyes will go to the 50. So next, so on calculation, I'll get EL equals to 8 into 10 power minus 4. Once again, it doesn't have any kind of units. So once I'm done with the lateral strain, now it's a time to solve for Poisson's ratio. Poisson's ratio is equals to mu is equals to EL by E. It's a ratio of lateral strain to longitudinal strain. So since we know lateral strain, just now we have calculated, and also we know the strain we have calculated, so we can find the value of Poisson's ratio. Mu is equals to 8 into 10 power minus 4 divided by 2 into 2.5 into 10 power minus 3. It's very simple. So I'll get the value of mu equals to 0.32. Students, make sure this value will not exceed 1. Will not exceed 1. If it exceeds, then it indicates that we have made something mistake. Then you need to go again cross-checking. So once mu is done, once I got the Poisson's ratio, now it's time to calculate elastic constants. The first elastic constant is equals to E equals to 2G into 1 plus mu. Just cross check. Can we solve for this formula? What about Young's modulus? Can we know? Yes. Do we know the value of Young's modulus? Yes. We know the value of Young's modulus. What about G, modulus of rigidity? No, it's unknown. What about Poisson's ratio? It is known. So we have only one unknown. So we can solve for this formula. Just substitute the values. E equals to 80,000. In the previous slide, we have the values. Just go and cross check it. 2 into G into bracket 1 plus mu. Mu is equals to 0.32. We have written 0.32. Just I'll continue with the proper simplification. So what I'll do is I'll write 80,000 as itself as it is, and I will calculate first in the bracket I'll calculate 1 plus 0.32. It becomes 1.32. So next what I'll do, I'll multiply 2 and 1.32. So 80,000. So I'll remove the bracket, then I'll multiply 2 and 1.32. 2 and 1.32. I'll get 2.64. So again on cross multiplication, I'll get 80,000 divided by 2.64 equals to G. Finally, G is equals to, this is the value of G. Once I'm done with this formula, then it's time for another equation, that is E equals to 3K into 1 minus 2 mu. Just I'll go on substituting the values. Just I'll substitute the values. This is a substitution of the values. First, what I'll do is, first I will try to solve the terms that are in bracket. So here 1 minus 2 into 0.32 is there. So first I'll multiply 2 into 0.32. First I'll multiply, I'll keep as it is, 80,000 as it is, 3 as it is, K as it is, and 1 as it is, minus as it is. I'll multiply 2 into 0.32. I get 0.64. Okay, still it is in a bracket. So I'll calculate 1 minus 0.64 in the next step. So that becomes 0.36. As it is, 0.36. Now in the next step, I'll multiply 3 and 0.36. 3 and 0.36. So 80,000 as it is, K as it is, 3 into 0.36 is 1.08. On cross multiplication, I'll get the value of K. This is the value of K. Students, this is that's it. This is the final answer for final answer of this problem. It's very simple, students. It's not difficult, because almost 80% steps are we followed from the basic problems. So only we have only 3 to 4 steps extra, and it's also very simple. If you go with the procedure step by step, then you can solve any kind of complicated problems. Just follow this method. First, you are supposed to find area, next stress, strain, Young's modulus, then lateral strain, then Poisson's ratio, then elastic constants. You keep in this mind, you keep these steps in your mind while solving any kind of problem. Just you apply these steps only. Okay. Okay, let's move on to the, I hope you have understood this problem, and let's move on to the next question, students. Yes. Right now the question is on the screen. Let me read out the question. A steel bar 50 mm wide, 12 mm thick, and 300 mm long is subjected to an axial pull of 100 kilonewton. Find change in length, width, thickness, and volume of the bar. Take E equals to 200 kilonewton per mm square. Take mu is equals to 0.32. Students, in the question he has given mu equals to 0.32, then it should be a problem on elastic constants. It is clear. Okay, now let me write the given values. What he has given? A metal bar of 50 wide. Wide is nothing but W. W is equals to 50 and the thickness is 12 So I'll write W into T equals to 50 into 12. Okay, since the formula becomes W into T for area. So that's why I have written like this. Then 300 long. So L is equals to 300 It is subject to the axial pull of 100 kilonewton. That is nothing but load. P is equals to 100 kilonewton. Find change in length. Delta L equals to question mark. Width. So students, he has not asked to find us. He has not asked us to find width. He has asked us to find change in width. So that is nothing but delta W equals to question mark. Delta T is equals to question mark, and delta V equals to question mark. And take E equals to 200 into 200 kilonewton per square, and also Poisson's ratio mu equals to 0.32. Okay, done. First cross check whether unit conversion is required or not. In case of P, I require unit conversion. That becomes P equals to 100 into 10 power 3 Newton. And in case of Young's modulus, again I need a unit conversion because he has given in terms of kilo. So E is equals to 200 into 10 power 3 Newton per square. Okay. So first I'll solve with the area. A equals to W into T. In the previous case, we have taken B into T because he has given breadth and thickness. In this problem, he has given width and thickness. So that's why I need to take W into T. Okay, students? Yes. The on substitution, I'll get the value of area, that is 600 square. Once I'm done with area, then I'll go for stress. Stress equals to F equals to P by A. So do we know the value of F? No, it's unknown. What about P and A? Yes, they are known. So we have only one unknown. So we can solve for this formula. F equals to 100 into 10 power 3 divided by 600. The final answer is 166.6666 Newton per square. Then strain. Strain is equals to E equals to delta L by L. E equals to delta L by L. So just do we know the value of E? Do we know the value of E? Strain? No, it's unknown. What about delta L? No, it's unknown. So we have two unknown. So if we have two unknown, then it is difficult to solve. So what I should do, just skip that formula. Just skip the formula, then go for next one. Next is Young's modulus. What's the value of formula for Young's modulus? E equals to F by E. Just cross check. Do we know, can we solve for this formula? What about, do we know the value of Young's modulus? Yes, we know. What about stress? Yes, we know. And what about strain? No, unknown. So we have only one unknown. Just substitute the values. So on substitution, this is the values, and on cross multiplication, I'll get, so E equals to 166.6666 divided by 210 power 3. Okay, with the help of a calculator, I'll get the value of E, that is 8.33 to 10 power minus 4. It has no units. Once I'm done with Young's modulus, instead of going to the next step, I'll come back to the previous formula where I couldn't solve it. So I'll come back to the strain formula. Once again, I'll write the strain formula. Strain E equals to delta L by L. No, again you cross check. Can we solve the formula? Can we solve it? Do we know the value of E? Here in this case, if I check in the given data, it is unknown. But right now we have calculated E, so it is known. What about delta L? It is unknown. What about L? It is known. So we have only one unknown. So we can solve for this formula. E is equals to 8.33 into 10 power minus 4 equals to delta L as it is divided by 300. On cross multiplication, I'll get like this. And finally, delta L is equals to 0.249. So units, I have missed the units. I am supposed to write the units here. It is in terms of mm, 0.2499 This is a unit for units of delta L. Okay, students. So on after finding out the strain, so I have done with Young's modulus. Then I'll go with the lateral strain. What the formula for lateral strain? In the previous case, we have studied EL equals to delta B, delta W by W is equals to, or delta T by T. This is the formula for lateral strain. In the previous case, it was a breadth. So in this case, he has given a width. So EL equals to delta W by W or delta T by T. Just cross check which formula I need to use. Should I use delta W by W or delta T by T? So let us cross check one by one. So do we know the value of lateral strain? Lateral strain is unknown. We have one unknown. What about delta W? Delta W is unknown, two unknown. So we cannot use this set. Okay, students, is it clear? We cannot use this set. Okay, now let's cross check with another set. As we know, delta L is unknown, so he has not given the value. What about delta T? Do we know the value of delta T? No, delta T is unknown. This is unknown. What about value of T? So it is known. Since in this case also we have two unknowns, so we cannot solve for this formula also. Since we cannot solve for both the formulas, then I need to skip. I need to go forward. Okay, so the next step is Poisson's ratio. Poisson's ratio is equals to mu is equals to El by E. Poisson's ratio El is equals to El by E. Just cross check. Do we know the value of Poisson ratio? Do we know the value of Poisson ratio? Yes, it is 0.32. Yes, given. What about El lateral strain? No, we have not. We don't have any kind of value for lateral strain. What about E? Yes, we have the value for E. So since we have only one known, that is El, we can solve for formula. So on substitution, I'll get 0.32 is equals to EL divided by 8.3333 into 10 power minus 4. On cross multiplication, I'll get this equation. So with the help of a calculator, I can go for calculation. Finally, I'll get a lateral strain as EL equals to 2.6666 into 10 power minus 4. So this is all about lateral strain. Students, I hope you are understood up to this slide. Now let's move on to the next slide. I mean, next set of calculation. Okay, done. So next set, after calculating the lateral strain, I'll go with the directly with the lateral strain, because in the previous case we have not we didn't get any value for any answer for lateral strain. That is why we have skipped. So once we got the value of once we have solved for Poisson's ratio, I'll go back to the lateral strain. That is, lateral strain is equals to El is equals to delta W by W or delta T by T. So answer, I'll take one by one. El equals to delta W by W. On substitution, El, this is the equation. So on cross multiplication, I'll get the value of delta W, that is 0.0133 mm. It's very simple. So in this case, again, I'll take EL equals to delta T by T, because I have used only delta W by W. So this is one more set. So I'll take another set, delta T by T. So I am taking this set only because he has asked us to find delta T and delta W. That's the reason I am taking another set of formula. If not, I would have neglected and I would have gone for calculating the elastic constants. Okay, EL equals to delta T by T. On substitution, I'll get this equation, because EL is nothing but 2.6666 10 power minus 4, delta T as it is, and in place of T, I'll put a 12. On cross multiplication, I'll get the value of delta T as a 3.199 into 9 into 10 power minus 3 mm. This is the value for delta T. And he has asked us to find delta V. So in order to find the delta V, we need to do some procedures. First, we need to find the lateral strain formula. EV equals to delta V by V. Students, this is a formula for volumetric strain. Volumetric strain, EV is equals to delta V by delta V by V. So we are supposed to find a delta V. Students, we are supposed to find a delta V. We need to find this one. Okay, we need to find this. So in order to find delta V, I should find EV, volumetric strain, and volume. So first I'll do this one. First I'll calculate the volume. V equals to A into L. As we know the value of area and also the value of length, so I'll get volume is equals to 18,000 mm cube. This is the value of volume. Since right now we got the value of this V, now it's a time to find out the value of EV. If I find V and EV, then automatically I can calculate delta V. So there's a formula for EV. This is EV equals to E into 1 minus 2 mu. So we know the value of strain, and also we know the value of Poisson's ratio. Then just on substitution, I'll get the values. So this is the substitution. EV equals to E is nothing but 8.3333 10 power minus 4 in bracket 1 minus 2 into 0.32. First, I'll calculate 2 into 0.32. Yes, students, this is a step after substitution. Then just what I'll do is I'll calculate the terms that are in bracket. First, I'll multiply 2 into 0.32. So this is the value I'll get. EV as it is, this 8.33 as it is, 1 as it is, 2 into 0.32 is 0.64. Okay. Next EV is equals to, next EV is equals to, as it is, I'll calculate 1 minus 0.64, that is 0.36. On multiplication, I'll get EV is equals to, this is the value. Once I get the value of EV, then I'll go back to this formula and I'll substitute the values. So EV equals to delta V by V. On substitution, I'll get EV is nothing but 2.99 into 10 power minus 4. Delta V is nothing but, as it is, we are supposed to find V is nothing but 18,000,000. On cross multiplication, I'll get the value of delta V. Delta V equals to 53.9982. Students, again, you are supposed to write this as mm cube. Yes, because it is in terms of volume, so you are supposed to write cube. Okay, if it is in delta L, I should write it is in terms of volume, so cube. Students, this is the problem, this is the solution for the given problem. I hope you have understood this solution. Okay, students, these are the two important problems. I have covered all the variety of problems. I mean, possible variety, possible questions, that is possible chances of asking you a question. So these two are very important questions. So this is with the help of this question, you try to solve different problems, n number of problems. Okay, so in the next class, and I'll deal with another topic, that is cylinders, thin cylinders. And after going to the thin cylinders, there are some set of problems in thin cylinders. Then after finishing the thin cylinders, our chapter will get completed. Okay.